Hello, I'm Lulu Zhu from Farrar's third period, and today I'm going to be talking about the mean value theorem for integrals. So what is the definition? Well, the official definition is, if f is continuous from a to b, there is a c in a to b such that f of c equals f average equals 1 over b minus a integral a to b f of x dx. Oftentimes in questions they refer to the thing as, oh, what is the average value of this thing? So that's why they would write it as f of avg. So you should recognize that phrasing and know it's referring to the IVT for integrals. And this equation, 1 over b minus a of integral a to b f of x dx, is the equation we're going to be using to solve for our f of c's. And you can rewrite this equation as integral of a to b f of x dx equals f of c times b minus a. And many books use this equation to solve for c after solving for f of c, but I think there's a much easier way, and I will show you guys how to do that later on in the video. So what exactly does the mean value theorem for intervals mean? Well, I'm going to try to graphically explain it. If you got a region from a to b and you have a curve, you can easily find the area under the curve. But the mean value theorem, it says that there's a value of c in between a and b, and where that c hits the curve, if you draw a rectangle with that place, the area of that rectangle is going to be equal to the area under the curve. So this blue section is equal to this pink section. So the equation we talked about before that we're going to use, how did it come into play? How did it turn to this? Well, let's start off with a standard from a to b, y equals f of x. So how do we actually usually find the average? We usually add up all the values and divide it by how many values there are. So if we write that in mathematical terms, we would get this equation. F of x of 1 plus ... plus f of x of n divided by n. And we know that the distance between the values is theta x equals b minus a over n. So what if we solve for n? We get b minus a over theta x. And look, we can substitute it into this equation for n. So that's what we do here. So we get f of x of 1 plus ... plus f of x of n divided by b over b minus a divided by theta x. And if we simplify that, we would get 1 over b minus a times f of x of 1 times theta x plus ... plus f of x of n times theta x. And in order to simplify this thing in the middle, we can just change it to this. And the main issue we have right now is as n increases, the distance between the values is going to get smaller, and that's good. We want that. But right now, we don't have that. So if we make n go to infinity, then there would be virtually no difference between the values, no distance between the values. So that's why we do limit as n goes to infinity of that equation. But look, isn't this just the integral equation? Yes, it is. So we simplify into the integral version of it, and we get this result, which is our mean value theorem formula, basically. I'm going to do 3 examples, and the first one is this. So from negative 1 to 5 over 2, f of t equals t squared minus f times t plus 6 cosine times of pi t. Find the average value. So when they say average value, they mean f of c. So we just plug into the equation. It's 1 over b minus a, so 5 over 2 minus negative 1, integral of a to b, so negative 1 to 5 over 2, of f of t, which is that long thing. And then we plug this into our calculator, and we get negative 1.621. And that's your answer, and this is f of c. Now this question, this example, it deals with c now. So it's saying from -5 to -6, f of x equals 4 over 2x plus 6 squared. Find the value of c that satisfies the MVT for integrals. Well, let's first try plugging it in just into the equation. So we would get this result, 1 over -5 minus -6, integral of -5 to -6, 4 over 2x plus 6 squared dx. But notice how my interval is phrased. It's from -5 to -6, and that's from right to left. But normally we go from left to right, don't we? So in order to make it more normal, all we have to do is flip the interval and put a negative sign out front. So we get this. And you could plug the previous thing into a calculator, but for some reason my calculator has an issue where it doesn't give me the negative it's supposed to have, so you end up getting the wrong answer. So I would highly advise just doing the second step in the first place, because you can show off your intelligence, and it's more of a just in case thing. So once we plug that into a calculator, we get f of c equals 0.16667. But now we need to find c. It's asking for c. So how do we find c? Well, it's easy. We set c equal to our equation. So that will be 0.16667 equals 4 over 2x plus 6 squared. Because f of c is technically our y value, and we want to find our x value that corresponds with that y value. So of course, we just set it equal and find x. So after solving, you get these two results, -0.55051 and -5.4495. But notice how -0.55051 isn't in the interval of -5 to -6. So therefore, it can't be one of our answers. So that's something you should always check, especially if you get two answers at the end, because it might not be in the interval and then it wouldn't qualify as an answer. Now this third example, I think Farrar would like this a lot. It's very FRQ-y, I suppose, and it's not something you usually see. And it's a word problem too. So at different altitudes in Earth's atmosphere, sound travels at different speeds. The speed of sound s of x in meters per second can be modeled by this giant thing, where x is the altitude in kilometers. What is the average speed of sound over the interval 0 to 80? So how do we do this? There's multiple equations, there's multiple sections. Well, we're going to take advantage of that fact, and we're going to separately find the area under the curves. So for example, in this first section, it's from 0 to 11.5, and the equation -4x plus 341 is applied there. So we just use that to find the area under the curve there. And we're going to do that for all 5 equations. So you get all these answers, and then you add them up. So you get from 0 to 80, s of x dx equals 24,640. Well, how do we change this into a mean value thing, into the average value? Well, the average value is just this equation, but in front of it, it's 1 over b minus a. So that's all we have to do to it. We just do 1 over b minus a, which is 1 over 80 times that thing we just found. So it'll just be 24,640 divided by 80, which would get us 308 meters per second. And make sure you remember units, because units are really, really important, and they're always worth some points. And they're just really not worth losing points over, because you know what you're doing, it's just a unit. So I think the mean value theorem for integrals, it's really, really easy. There's really nothing much about it. But the issue is there's many small things that you could really easily mess up on. So my main hint would be just to double check your answers, make sure you didn't mess up in a small place, because it's not really worth it to lose points in a small place when you actually know what you're doing. And it's really annoying when that happens. So just check everything you do, and that's my main thing that you should know. And that's all for my video. I hope this is helping whatever you're doing. I hope you don't fail whatever test you're studying for, or it's because you wouldn't be on this video otherwise. Thank you. Have a good day. Bye.